For decades, security meant auditing physical assets and building thicker walls. This was the fortress model, a strategy assuming safety scales with physical mass. Modern threats operate in a different environment. Systems are now brittle, anxious, nonlinear, and incomprehensible. In this landscape, a thick wall is an irrelevant defense. Whether the trigger is a cyber intrusion or a financial clearing failure, modern crises bypass physical barriers entirely. They target a system's invisible architecture, the digital customs ledgers and identity backbones that keep a society functional. Measuring the operational muscle of an organization is a useless metric. True vulnerability is found in the hidden digital and operational dependencies that hold those muscles together. When a complex network unravels, the failure isn't uniform. It typically begins at a single node, where the entire weight of the network's dependencies converges. This single point of failure is the pivot domino. If it collapses, the resulting systemic cascade is unstoppable. Measured through node centrality, it acts like a joint lock. Apply pressure to that one point, and the entire system loses mobility. Modern systems fail because these invisible, high-traffic dependencies are left unmapped and unprotected. To prevent this, leaders are moving toward network sovereignty. This requires shifting from owning the individual wheels of a system to connecting the entire drivetrain through a resilient, living operating system. The first step is a nerve-based audit. Instead of counting physical inventory, organizations map their invisible architecture to locate every pivot domino within their system. This mapping creates hazard-independent preparedness. By designing a network to absorb entropy universally, the specific trigger of a crisis, be it kinetic, financial, or digital, becomes irrelevant to the system's ability to remain coherent. A system that can reorganize and adapt in real time functions like a biological nervous system, absorbing shocks rather than shattering under them. The defense against a systemic cascade is the isolation of the nodes. If a network can be severed without losing its function, it cannot be taken down by a single failure. This is the 72-hour autonomy standard. Every critical node within the national mesh must be capable of autonomous operation for 3 days under severed conditions. Automated systems rely on degraded condition protocols to stabilize instantly when cut off from central command. Continuity of flow is maintained through sovereign fallbacks, offline QR protocols, and encrypted SMS channels that bypass compromised global clouds to keep local nodes communicating. This autonomy is verified through quarterly severance drills, where central command is simulated as offline to ensure the fallbacks actually work. In this framework, resilience is defined strictly by a system's ability to function while severed apart. When a network is severed and a node is isolated, a new vulnerability emerges: the lack of central oversight. This is addressed through human integrity density, or HID. It is the ethical failsafe that prevents external coercion or elite capture when a node is operating in total isolation. Isolated operators rely on their own ethical bone density and a deep understanding of commander's intent to make critical decisions without waiting for a signal that may never come. Technology provides the architecture, but the character of the human node is the final unbreakable barrier against a total system collapse. When resilience is integrated into the initial design of infrastructure, it stops being an insurance cost and starts producing a measurable return. By synchronizing local AI with sovereign compute, systems eliminate the friction and redundancy found in traditional siloed networks. This synchronization allows for the deployment of anticipatory digital twins. These twins simulate transboundary crises in real time, allowing the physical system to reorganize its logistics before a disruption even hits. This optimization yields a resilience dividend. In practice, this architecture targets a 30% reduction in energy consumption and an 18% improvement in logistics flow. By 2026, power will be defined by the resilience of the flow. The engineering of character into the infrastructure ensures the system holds without the need for constant central oversight.